Good evening, Puranjit.
Yes, ma'am. Good evening.
Good evening. So we started with our chapter that was electrolysis.
Yes, ma'am.
We have
I
completed.
think
Yeah.
we have done all the preparations.
No, we have not done all the preparations. We have done just few of them.
Yes, ma'am.
Okay. Let's just have a quick revision, whatever we have studied till today. It's been third day we have been studying this chapter, right? So how you're going to define the electrolysis?
The electrolysis is a decomposition of a compound in molten or aqueous solution state into ions at the respective electrodes when electricity is passed through it.
Okay. So how would you define an electrolytic cell?
An electrolytic cell is a non-conducting material in which the electrolyte is kept in.
What are the components we include while taking the electrolytic cell?
Components include like electrolytic cell as in whole, everything.
Yeah, what is included inside that electrolytic cell?
Inside the electrolytic cell, there are the electrodes. It is the anode and the cathode. Anode is the negative electrode, and anode is the positive electrode, and cathode is the negative electrode. And in which there is an electrolyte in solution or aqueous state, which has to be decomposed by electricity. And there is the battery through which it is connected, and the vessel in which the electrolysis will be done.
Okay, so you told that we include electrodes also. So of what material the electrodes should be made up of?
Electrodes should be made up of a conducting material. Electrodes also are of two types, like active electrodes and inactive electrodes. Inactive electrodes include copper, platinum, etc. And active electrodes are the electrodes which take part in the reaction. And active electrodes example is copper. I said copper by mistake, inactive. It is active electrode.
Yes,
Uh,
copper is
uh,
an active electrode.
yes, copper. And then you have, I think, nickel also is active
Yes,
electrode, right?
nickel and silver. They all are
Yes,
active electrodes. And what
yes.
are inert electrodes?
Inert electrodes are the electrodes which do not take part in the reaction and do not alter the uh, rate of reaction or anything in the reaction. The
Example?
uh, examples are graphite. You have graphite electrodes. I think,
Okay.
yes. This
Okay.
minute I cannot
So
think of
in
more example like graphite is there and
yeah, you can include graphite. Further, you can include iron and platinum. Graphite and platinum are
yeah,
the common ones, but depending upon the ease with which they are available, we take graphite.
yes.
Okay, so you told me that electrolysis is a decomposition of a compound by the passage of electricity. So, in which state your compound must be?
Aqueous or solution state.
It must be in the aqueous or solution state and not in the solid or gaseous state?
Because electrolytes are electrovalent compounds and they have strong electrostatic force of attraction between their atoms.
Okay. Further, can you tell me in which category you are going to include the lead bromide molten electrolytes or the non-electrolytes?
Well,
I asked you that in which category are you going to include the molten lead bromide electrolytes or the non-electrolytes?
molten lead bromide is a strong electrolyte. It
And
is
why?
electrolyte.
Yeah. And why you are considering it as a strong electrolyte? Give your reasons,
I,
some reasons to support your
yeah,
answers.
it is a strong electrolyte because it completely dissociates into ion at the respective electrodes.
Okay, so not enough.
A complete electrode. So what you have to include more?
You have to include like since they are strong electrodes, they are the good conductors, poor conductors, or non-conductors.
Yes. Yes, it is a strong electrode. It is a good conductor of electricity. It has strong force of
Mhm.
attraction between its molecules. It conducts electricity in molten or aqueous solution state. Because of the same, its strong forces, that is electrostatic force of attraction, and
Okay. And what about
yes,
its
that's all.
dissociation? How they gets distributed? Like almost completely, partially? How?
Complete dissociation,
Almost completely. In which state?
almost. Aqueous solution state both.
Okay. So in strong electrolytes, what is the general product? Ions and molecules, or
Ions,
what?
ions.
Okay. Magnesium hydroxide is considered as a weak electrolyte. Give 3 points to support your answers.
Magnesium electrolyte is considered a weak electrolyte because is magnesium is located in the down series of the electrovalent series, so it won't get discharged easily. And
Hmm.
hydroxide, it is the same for hydroxide also. And then it does not dissociate into completely into ions. It also has ions, but some unionized molecules also. And it is not exactly a good conductor of electricity. It's a
It is a
good
poor
conductor of
conductor.
it is a poor conductor, and it's a
Hmm.
non-electrolyte again.
Okay, when you are giving the answers of like these question, magnesium and hydroxide, you have to just consider the entire compound as a whole compound. Not you have to not break it like magnesium is this or hydroxide is this. Okay, because the entire magnesium hydroxide is a base, is a solution. Okay, so we won't get the magnesium differently and the hydroxide differently. Obviously, by the passage of electric current, they are going to be formed into ions. Right. Okay. So when any compound is being dissociated, it is being dissociated as positive ions and the negative ions. So what is the respective term we use for the positive and the negative ions? Are you there, Puranjay?
Sorry, I got disconnected. I was saying that the positive ions are cations that go to the cathode and negative ions are the ions that go to the anode.
Okay. So what is the final product of the electrolysis? Like if I say that electric current is passed in a like in a summaries, as if I say that in a aqueous solution state, there is a passage of electric current in the compound, which leads to the dissociation of the electrolyte. So it results in a discharge of ions. Is there something
Yes,
else you'd like to add in the definition?
they generated ions at the respective electrodes are neutral.
As the neutral atoms. Okay. So between cathode and anode, which electrode the reduction happens and at which electrode the oxidation happens?
Cathode is reduction and anode is oxidation.
Anode is oxidation. Okay. So generally the negative ions they are deposited at which electrode, the cathode or the
Anode,
anode?
anode.
Okay. Then as you told, the anions migrate to anode and the cations migrate to cathode. So the anode is the which terminal of the battery?
Anode is the negative terminal. Yeah, anode is the positive terminal and cathode is the negative terminal of the battery.
Yes, this time you told correct. Okay. So between anions and cations, the anions and cations, who are the negatively charged ions and who are the positively charged ions?
Anions are the anions are the negatively charged. Anions are the
Ions.
negatively charged and cations are the positively charged cations. Ions.
Okay. Between anions and cations, who accept the electrons and who gains the electron?
Between anion and cation, the anions
Hmm.
gain the electrons and cations accept the electrons.
Cations accept the electron and anions lose the electron. You told anion gains the electron. Okay. Okay.
I
In the
got that.
mechanism of electrolysis, the postulates given by the Arrhenius, the first point he stated that the electrolyte on dissolving gives the free cations and free anions, and that's what it
Yeah.
leads to the flow of electric current. So according to you, what leads to the flow of electric current? What is the main term we use?
Ions.
Yes, flow of
Ions.
ions. Okay. Then how would you define the degree of dissociation in an electrolyte?
The degree of dissociation is extent to which a compound breaks up or dissociates when aqueous or solution state when electricity passes through.
Okay. In his postulate, he told that the number of positive charges are equal on the number of negative charges. Do you agree with this statement? If yes, so give support to your answer.
Yes, I do agree because the
Mhm.
number of electrons gained by the anode is equal to number of electrons donated by the cathode.
And what do we call this particular state?
A redox reaction because anode gains the electrons, so gain of electron oxidation, loses the electrons, that is loss of electrons, reduction. Oxidation and reduction from the redox reaction.
I didn't ask the kind of reaction. You told me that the number of positive ions
Aqueous
are
or
equal.
solution state. Aqueous or solution state.
No, still not correct. I asked you that the number of positive charges are equal to the number of negative charges. That means the left hand side is equal to the right hand side. So, firstly, you told me the redox reaction. I didn't ask you the kind of reaction. Secondly, you told me the aqueous solution state. No, that is a state which is known as the equilibrium state, right? When both
Yes.
the left and right hand side are the balanced one. Okay, then the amount of electricity conducted by the electrolyte. You know very well the electrolyte is responsible for the flow of electrons since we are using a conducting electrode, which can be an active electrode as well as the inert electrode. So the amount of electricity, how much amount of electricity must be supplied to the electrolyte? It depends on what?
The compound itself.
No, the electrolyte, the concentration of the electrolyte.
Uh, Concentration of the electron depends.
Because it is the electrolyte which is responsible for the conduction. Like for example, if you are taking copper sulfate solution, it is a good electrolyte, that you can say strong electrolyte, right? But if you take the ammonium hydroxide, it is a weak electrolyte. Obviously, if you will supply a very large amount of current, the solution itself is very weak, right? So the bulb which you connected obviously will glow in a very dim light. So it depends on the concentration of the electrolyte. Okay, then coming towards the characteristics of electrolysis, the preferential discharge of ions, that which ions are going to be discharged at first or which ions are going to be discharged at the last, depends on the position of.
The position in the electrovalent series. Higher the atom, the more probability is going to be discharged, and lower the less probability is going to be discharged at the respective electrodes.
So electrochemical series is all about metals, non-metals, or both?
Both
No, it is all about metals.
yes, metals. Like
Yes.
there is for ions, cations and anions both, right? SO4 2 minus and then
No, basically that series is for the metals. When these metals dissociate, they form the cations. So for your convenience, they have given you the cation also. Like for example, potassium will form the K positive one cation, like this way. Okay.
yes,
Then we have that between the cathode and the anode, on which electrode the metals are liberated.
cathode.
Cathode. Okay. And the electropositive elements are the metals or the non-metals?
Are the metals because they
Rian,
donate
today ma'am
electrons
is on
and
leave.
form a positive.
Rian, can you hear me? He is
Uh,
left. Okay, carry on.
Okay. So we were at the and into which electrode are the electronegative elements liberated?
Theta, uh, anode, sorry, anode.
Anode. Okay. Then we came to our two give reasons, important give reason yesterday that we studied, that the solid sodium chloride is a non-electrolyte. But when it is infused on molten aqueous state, it is acts as a very good electrolyte and dissociates very well. So how you are going to define all of the reasons in a 3 marks question, 3 or 4 marks question? Very point
Because
to point.
Ionic compounds, for example, NaCl contain one metallic element and one non-metallic element. For example, in this case, Na plus and Cl minus. These ions are not free but held together by a strong electrostatic force of attraction by the respective electrodes, and hence they cannot conduct electricity in the solid state. So they need because the free ions are not there, which are essential, which are needed to conduct electricity in the solid states. Hence, when an ionic compound is heated strongly, they gain kinetic energy and lose break loose and move freely. The molten solution, hence, thus, the molten solution becomes a good conductor of electricity. And same when they are in aqueous state, since water is a polar solvent, it exhibits a slight distribution in its charge molecule. The water H plus has slight positive and OH slight negative, and hence Na
Mm-hmm.
plus goes to O minus and Cl goes to H positive, and they get separated, and hence they form a Na plus and Cl minus ions.
Excellent. I hope you're not using the book, right? You are just giving answers by yourself.
I have the book, but I'm not using it.
Okay, so try to just not look into the book, okay? Okay. Then coming towards our covalent compounds, as you know, NaCl is was we were talking about was the electrovalent compound. Coming towards our covalent compound, the polar covalent compounds. Can you give me the example of some polar covalent compounds?
Yes, polar covalent compounds, for example, HCl, HCl, and then polar
HCl means
covalent
the hydrogen chloride or hydrochloric acid.
hydrogen chloride.
Okay. So I was asking you that in polar covalent compounds like ammonia, hydrogen gas, they are non-electrolytes in the gaseous state, but they
Yes.
ionize in the aqueous solution state. So what is the factor which is leading to the ionization in the solution state, but not in the gaseous state?
Polar covalent compounds are compounds which exhibit charge distribution between their atoms. So
Yeah,
hence HCl is a polar covalent compound in which H plus develops a slight positive charge and Cl minus develops a slight
negative
negative
charge.
charge. Hence
Hmm.
hence there is total repulsion like delta negative and delta positive. However,
Hmm.
hydrogen chloride source does not conduct electricity in solid state because when it is in aqueous state the water H plus of the HCl combines with water, that is H plus plus H2O, which forms a hydronium ion, which is a good conductor of electricity, and hence the HCl compound is able to conduct electricity.
So where does the if you told me that between H plus and Cl minus ion, the H plus combined with the molecule water H2O and gives hydronium ion. So what about the Cl minus ion? Where they will go?
Cl minus ion will remain in the solution.
Okay, they will remain in the solution. So that's why the hydrogen chloride in the gaseous state or in the pure liquid state does not conduct electricity. Okay, so one more question. As I told you, the copper metal and the copper sulfate. Right? Copper is a metal and copper sulfate is a solution. So obviously, since copper is a metal and copper sulfate is an electrolyte, so how can you define the difference between the both of them?
Copper conducts electricity due to the flow of electrons, and copper
Mm-hmm.
sulfate conducts electricity due to ions. Copper does not lose its properties and does not lose its identity while conducting electricity. Copper sulfate, while conducting electricity, differentiates into ions, that is Cu2 plus and SO4 2 minus. And copper itself is a metal and is a good conductor of electricity in solid or liquid state, while copper sulfate is a good conductor is an electrolyte. It is a good conductor of electricity in liquid or aqueous state. And then
Mm-hmm.
one more point. Uh,
It's decomposition and about the formation of new products.
yes, in case of it does not form any new product, it forms new product. And I said everything. I think I said 5 points.
Okay.
Yes,
Okay,
yes, I
moving
said.
forward, yes. Moving forward, we have already learned the acid, bases, and salt, right? And the strong and the weak electrolyte. Then coming towards our electrochemical series, you told me that the electrochemical series, the most reactive metal is placed at the top and the least
Yes.
reactive metal is placed at the bottom. So depending on which criteria the electrochemical series is arranged.
Depending upon the ease at which metals lose their electrons. For example,
Okay. Mhm.
potassium loses its electrons very easily to other non-metals, so hence it is
Mhm.
placed at the top of the series. And as we go decreasing the
Mhm.
down, the increase of reduction happens.
Okay.
Yes.
Then you have the selective discharge of ion. How would you define the
Excuse me,
particular
ma'am.
definition?
Excuse me, ma'am. Ma'am,
Yes.
reduction happens when there is loss of electron, right? Like, for example, sodium gives one electron to chlorine. That is reduction, right?
Reduction happen when there is loss of electron, right? You are correct.
So, at the bottom, as we go, how increasing reduction, Ag does not lose electrons as easily as compared to sodium or potassium.
Because it depends on the atomic number. Like for example, you told me the calcium. For example, let us take copper or silver, right? So copper is forming copper to anions, and silver is forming Ag single cation, right?
Yes.
But your question is that why copper is means it's placed at bit top and silver is placed a little bit bottom, right? This is your question.
Yes, good.
Yeah. So
My
as you
question is like, why is increasing reduction when we go down? Like it should be increasing reduction when we go upwards, right?
reduction means the loss of electron, right? So if you take any two
Yes,
example, if you take the example of copper or if you take the example of silver, right? In the periodic table, if you refer that the first chapter we studied, the copper it has atomic number 29, right? While in
yes,
the case of silver has atomic number 47. Okay, so when you will classify them according to their electronic configuration, then you will see that the number of shells in the case of copper are less, and in the case of silver will be one shell more, right? Because the copper belongs to period 4 and silver belongs to period 5. So since the number of shells are increasing, number of electrons are also increasing. So the tendency of the silver to release the electron would be easier, because then in this case it will depend on the ionization potential, the tendency of an electron to lose the its electron from the outermost shell. If you will make the
yes,
electronic configuration respectively like of 29 and 47, then you can conclude from that that in the since silver is having Ag1 plus, it means in its valence shell it might be having the less number more number of electron. That's why it can lose the electron more easily. If we consider copper is having Cu plus 2, right? It means it must be having two valence electron in its outermost shell that it is losing. So tendency of the silver is much more easier than that of the copper. But coming in terms of the ionization potential, the case is reversed there. So we have to not go towards the valency, we have to look for all other factors also. Atomic radius, the electronegativity, the main importantly the ionization potential.
yes, ma'am. Because both potassium also K plus has K1 plus and Ag also has K1 plus.
Yes, as you can see, if we go over the valency K plus 1, then we have Ca plus 2, then again Na plus 1, then we have again Mg plus 2, that is 1 and 2 alternate. If we go in according to the valency, then all the positive ones should be placed at the top, right? And all the positive 2 must be placed at the bottom.
Yes.
Okay. Then coming towards our next topic, how would you define the preferential discharge of ions?
The preferential discharge of ions is depending upon discharge the ions at the present in an electrolyte at the respective electrolyte, like which ion is going to be s- uh,
Discharge.
ionized at the discharge at the respective electrodes.
Okay. It includes the three factors, the selective discharge of ion. The first one is the its position, second is the concentration, and third is the nature. So
Yes.
talking about the nature, how would you define that? How would you justify that the nature of the electrode is responsible for its selective discharge?
Because if you take example of copper, CuSO4 sulfate solution, the if the electrodes are of copper and cathode and anode are copper, then the reduction at anode will be Cu, it will lose two electrons to become CO2 plus, and the product will be CO2 plus ions. So hence ions, the anode itself will start taking part in the reaction. So they alter the rate of reaction, or else if we instead if we would take a non inert electrode, for example, if I take platinum, the result will be water and oxygen. So this shows that the electrodes have a lot of impact in the electrolysis. Inert electrodes do not take part in the reaction, and active electrodes take part in the reaction.
Okay, good. So, for example, if you take the copper sulfate solution, if you are electrolyzing the copper sulfate solution, and if we take the electrode copper that is at the cathode
Yeah.
and the copper at the anode, so the reaction of anode will be the formation of the copper ions, obviously. So, these copper ions will be formed where? At the cathode or at the anode?
Copper ions, could you just repeat it now?
Yes, I
Question.
asked you if we are electrolyzing copper sulfate solution and the electrodes also we have taken both the electrodes are of copper. So the reaction we will get the formation of the copper ions, the product. So these products will be formed at the respective cathode or at the respective anode.
The copper, that is the copper metal, CO2 plus and neutral state will be there at the cathode. But again, when HOH minus and SO4 minus go to CO2 plus, what is that? Electrode, the
Mhm.
CO2 plus is above them. So hence it loses the electrons in itself and becomes CO2 plus. It takes part in the reaction. It alters the rate of reaction.
So since copper is an active electrode, we would be getting copper ions at towards the anode or at the cathode.
Actually, both.
Not both. It is an active electrode. We have taken the copper as a both cathode
Cathode.
at the anode readily, most readily, because it's an active electrode. It's going to participate
Active electron.
in the reaction.
Yes.
Yeah. Okay, and if we are taking again, we are doing the electrolysis of copper sulfate, and now this time the electrode we are taking at the cathode is copper, and at the electrode we are taking anode towards the in the anode is platinum, right? So, in the what products will be formed at the reaction at anode?
At this point, OH minus ions and SO4 2 minus ions
Mhm.
will go at the anode, but OH minus ions will be discharged due to its higher position in the electronegative series, and then it will form OH minus ions will gain one electron and form OH minus into two. That will form 2H2O plus O2, that is water plus oxygen.
Okay, these reaction you have to just write down and practice also because in terms of speaking they looks very easy, plus and minus and negative and cations and anions, but just
Yes.
practice. Yeah, the
In
arrows,
the
the
exam,
reversible.
in
Hmm.
exam like somewhere I got confused like between anode like which is positive, negative, or which will
Yeah.
be discharged.
Hmm. That's why I'm saying some arrows are reversible, some arrows are only in the forward direction, right? So they all have particular meaning. If it is in the forward direction, it means the reaction is going towards left from left to right. And if it is reversible, that means since you are passing the electric current, so when electric current will be flowing, the reaction will be forward. And when the electric current stops, the reaction will again return to its product, to the reactant we have taken. Okay. In the selected discharge of ion, the second factor included was the concentration of ion. So, if the concentration of the ion is higher, then what is the probability of its being discharged?
Its probability of discharge is more as compared to the lower concentration. So at the respective electrodes, it will discharge more. Its probability is more basically at the
Okay,
respective
okay.
electrodes.
Yeah, I just asked this. Okay, talking about the position of the cations or anions, I asked you, as you have told, the lower the position of the ion in the electrochemical series, the dash is the tendency to be liberated. The lower, the greater, or the lesser?
More.
Yeah, more. Then yesterday, what we studied, I'm again starting with the yesterday's topic. Yesterday we studied the preparation of the molten or fused lead bromide, right? Do you want to explain me, or just I, unless you want me to take a revision of this particular topic also?
I did not study this, like, not
Okay, just let's have
really.
again a quick revision, no problem. So in this, the electrolysis of molten or fused lead bromide we are doing. The lead bromide, the formula for the lead is Pb and for the bromide is Br2. So the formula of the lead bromide becomes the PbBr2. Here you can see we have made a setup. In this setup, we have taken a Bunsen burner to heat. As you can see, the U shape. This is the crucible. China dishes are very small in size, and if you're taking the big apparatus for that, then we call it crucible. The crucible, the material of the crucible is made of silica, right? No glass, no metals, no non-metals, nothing but of silica. Inside it, as you can see, the two electrodes are present there, the anode and the cathode. At the anode, we have taken the graphite electrode, again being an active or the inert electrode.
Graphite is a inert electrode.
Inert electrode. And the other hand, we have taken iron or graphite. If you want, we can have both of the graphite electrode. We don't have any problem. Then in the crucible for the electrolyte, we have taken the molten lead bromide. Obviously, we have taken molten because it is going to conduct electricity in the molten state.
Mm.
Then we have connected both the terminals of the electrode to the both the terminals of the battery. The anode is connected to the positive terminal or the negative terminal.
Anode is connected to the negative, positive terminal. Positive. Positive.
Anode connected to the positive terminal, right? Okay. Then we have a meter here. As you can see, a capital H being shown to measure the amount of current we would be supplying, right? Okay. Now, as I told you, in the electrolytic cell, we have taken silica crucible. Electrolyte, we have taken the molten lead bromide. At the cathode, both the electrodes can be of graphite. We don't have any problem. The temperature must be between at 380 Celsius because that's the melting point of lead bromide. The current ammeter we have taken, it must be between 3 amperes. We cannot supply very much high current to the setup. Then as we will pass
Mhm.
the current to the molten lead bromide, obviously it is going to dissociate at its respective electrodes, the positive ions and the negative ions. So lead will be dissociating its respective positive ion, lead Pb plus 2 since it is a metal. The bromide being a non-metal or in the gaseous form will be Br minus 1, right? Now talking in terms
Yes.
of cathode and anode, all the metals as a neutral metal atoms will be discharged at the cathode. So lead being a metal will lose its 2 electron and will form the neutral lead atom, a neutral lead metal. So the lead ions are discharged at the cathode, and after discharging in the ions, they lose the electrons and they become the neutral atom. Same happens in the case of bromine. The bromine will gain electron and become the neutral bromine atom or neutral bromine gas. Then the bromine atom will combine with the other bromine atom forming the gas, that is a bromine gas, right? So now bromine
Yes.
ions, they are discharged at its respective anode. How they are being discharged? By combining or giving up the electron as a neutral bromine atom. Now, what ions are formed at which electrode? Now, in at the cathode, we are getting the lead metal. And how we can identify this lead metal? It must be in a silver grade deposit. Then, at the bromine we know very well it is a non-metal, but it's talking about its state. It will really be liberated in the form of gas. Which kind of gas, which color of gas? The bromine vapors will give the reddish brown fumes, right? So that's
Excuse
why
me,
we are
ma'am.
going. Yes.
My exams are on starting from third of the next month, that is January. So we'll
Mm,
be able to do in our syllabus in like 15 days, full book.
obviously. Yes.
It
We'll
will be
do.
done, right?
Yeah, it will be done.
Even like study of compounds or
Yeah.
organic,
in- Yeah. Because some chapters are lengthy and some chapters are strong. So we are going to balance it. Don't worry. But whatever we are
like
studying, you also keep
organic is
studying with.
lengthy and little bit hard also, like organic
No, it's
chemistry.
not hard. Don't just keep in mind that it is hard. It's very interesting. Like, for example, whatever chapter you are studying, you are just taking interest, right? So don't already just make your mind that it is hard. Obviously, the chapter is lengthy. I agree with you because the topics included are very much important and very much conceptual because this is the basic of class 11th you're going to study in 10th. That's why. Don't go on the length of the chapter. Just whatever you are studying, just read it with the interest. If you're not going to read it with interest, it will again take the double or triple time. And at last, what
Yes,
will
ma'am.
happen? You will just learn it. not understand it, and at exams you're just going to get it forget. Okay. Now coming towards our preparation of the fused lead bromide. Here I told you that in the electrolytic cell we took the silica. The electrolytic cell was made of silica. Why we have used silica and not any other material? Because the crucible was made of silica because it is non-reactive. The electrolyte we have taken molten lead bromide. It does not react with the silica. Further, as we have taken the Bunsen burner to heat our setup, it can withstand or it can tolerate such high temperatures. Also, silica is a non-conductor of electricity. So when we are passing the electric current through the electrolyte, the entire vessel is not conducting the electricity. So that's why, as I told you, electrolytic cell is a non-conducting vessel, right? Then we have solid
Yes.
lead bromide is a non-conductor of electricity. We have studied this many times because they does not have any free ions, just held together by the strong electrostatic force of attraction. That is a charge separation. The ions become free when they are becoming free when we are supplying the heat to them, when they are strongly heated. The atoms become free, the molecules become free, and they gain the kinetic energy, the motion become more random. Talking towards the metallic lead ions which are discharged at the cathode in the form of gray deposits, we and the bromine ions is liberated at the anode in the form of reddish brown fumes. The cathode, you know very well, is an electron donor, and the anode is a electron acceptor. Just going on above that, because yesterday we have already done. So bromine ions, they give up the electrons, resulting in the formation of the neutral bromine atoms. Already I made you understand. So neutral bromine atoms, they form the bromine molecules, combine with the bromine molecule, forming in the gas and the covalent bond. Covalent means sharing or transfer.
Sharing.
Sharing, good. So the reddish brown vapors of bromines are hence seen at the anode when the molecules they escape from the molten lead bromide in the form of gas. Talking about the reaction, the you have to include the three reaction. First is the main reaction, showing the electrolysis. Then after the electrolysis, you have to show the reaction what is occurring at the respective electrode. The first one is the cathode. So cathode we have lead ions gaining losing two electrons, forming the neutral lead atoms metal. Then we have the reaction at the anode, the bromine ions they lose electron, forming the bromine neutral atom, giving the relatively reddish brown fumes of ions. Coming towards our next preparation, we are at page number 114. That is the electrolysis of acidified water. Now, what is an acidified water? The acidified water, if we talk about, could you just give me an idea? Whatever is striking in your mind by the word acidified water?
We have add some acid like HCl.
Yes, means it means something acidic has been provided to that water. That is the word
Its
acidified.
its pH will decrease.
Yeah, its pH will decrease. Talking about the setup, as you can see, this is a setup. We have taken the two electrodes. Since we are talking about the water, obviously the gas will be involved. That is H plus and OH minus, and both are the gases, right? So we have
Yes,
taken
ma'am.
the two test tube, that is inverted test tube, right? And we have filled the water in both of them because we are doing the electrolysis of an acidified water. So at both the electrodes, we have taken the water inside the test tube, right? In the anode, talking about the material of the electrode, the anode is made up of the platinum foil. So platinum, again, inert electrode or active electrode?
Inert electrode.
Inert electrodes are not going to participate. Then both the test tubes at the respective electrodes are connected towards the end of the battery, and the setup is ready. Also, talking in terms of the electrolyte, obviously we are doing the electrolysis of the acidified water, right? So
Yes, ma'am.
water we have taken in the test tube, so the electrolyte must be certainly of the acid. So in the form of acid, we have taken the dilute H2SO4, not the concentrated. Again, dilute because we have to include the more quantity of water in them. Acidified water, right? Then we have electrode, we have taken the platinum foil at both the electrodes. The ordinary temperature we are taking, not high temperature. That's why we are not included the ammeter here. Then the current we are giving is the 3 ampere. Talking about the dissociation, when the electricity is passed to the acid, that is our electrolyte. So the H plus and SO4 minus are going to be separated. Also, the water we have taken inside the test tube at both the electrodes will give H plus and OH minus ion. Right? So now here, as you can see, we are getting the four ions here, two positive and two negative. right?
Yes,
So
sir.
we would be taking, as you can see there in the talking about the positive ions, we can see that both are the hydrogen ion, that is a common hydrogen ion, right? So when we are talking about the reaction of the cathode, the hydrogen ion will lose its one electron, sorry, will gain its one electron, forming the hydrogen as a neutral atom, right? So the hydrogen is discharged at the cathode. Talking in when the hydrogen ions are discharged at the cathode as the neutral hydrogen atom, they will accept the electron and they will form the hydrogen, that is the gas, which would be liberated at the cathode, right? And
Yes,
as you
ma'am.
can see, two volumes have been given, that is the quantity in terms of the gaseous state, like H2O. Then we have the reaction at anode. We can see anode two ions are being formed here, sulfate ions and the hydroxyl ion. So sulfate ions, it is present in the form of electrolyte. So it will remain in the solution, right? What will be happening to the hydroxyl ion? The hydroxyl ion will the hydroxyl ion will be discharged at the anode, and we will balance this reaction. That is, 4OH ion will decompose into the water and the hydroxyl ion. Water and the oxygen gas. Sorry. So the product which we are getting at anode would be the oxygen, which is present in only one volume. So we can conclude the reaction. At the cathode, we are getting the hydrogen ion, hydrogen gas, and at the anode, we are getting the oxygen gas. Now, how we are going to show the both the gases in the test tube? Now, as you can see, in the test tube, we have taken the water, and in the electrolyte, we have taken the acid. So both the gases will be formed above the water. As you can see, at the oxygen is formed in one quantity, that is one volume. Oxygen level is a much bit upper, and in talking about hydrogen, it is present in two volume. The level of the water is a little bit down. And why they are forming upward? Because obviously they are lighter than water.
Yes.
Yes. So as you can see, and can you tell me the when at anode or cathode where reduction is happening?
At reduction is happening at cathode.
Cathode, good. And the oxidation at the anode. So it is an example of which kind of reaction?
Redox.
Redox. Okay. Now coming towards our setup, we know very well the pure water is almost a non-electrolyte. Can you just tell me why it is a non-electrolyte? Pure water.
Because it does not have electrons to conduct electricity.
Okay. So it does not have electrons. So what does it have? The pure water.
Molecules, I think. No,
Yes.
molecules. Not.
Yes, entirely the molecules. No ions are there.
Yes, electron. Yes,
So
yes.
it can be just electrically decomposed. That's why we have added some traces of dilute H2SO4 as an electrolyte. We have not taken entirely the acids in them. We have taken dilute H2SO4, means the acid along with the more quantity of water in them. Okay. So electrolysis of acid-related water is considered to be an example of the catalysis. Again, dilute sulfuric acid is preferred to dilute nitric acid. We could have taken the nitric
Excuse
acid
me,
also.
ma'am.
Yes.
Ma'am, could you explain why electrolysis of water is considered to be an example of catalysis?
Okay. The electrolysis of acid-related water is considered to be electrolysis catalyst, because you know very well the catalysis does not itself participate in the reaction, but it alters the rate of reaction. Similarly, for the catalysis, we have taken the acidified sulfuric acid. So only the water ions and the sulfate ions are being included. The entirely the sulfate H2SO4 is not being dissociated. We have just taken traces of acid. That's why we are calling it a dilute sulfuric acid, right? And the dilute sulfuric acid, the ions will be dissociated as the H plus and SO4 minus, and in water it will be dissociating in H plus and OH minus ion, leading to the mole polarity of the solution, means ions are produced in excess, giving it a push, and it will be acting as a catalysis. For this purpose, we have not taken separately any metal or a non-metal for the catalysis. Like we could have taken nickel, could have taken platinum for the catalysis. Just now, whatever we have said that catalysis can be a metal, can be a non-metal. In this case, the catalysis is being done by the ions.
Yes, ma'am.
Then again, the dilute sulfuric acid we have used and not the nitric acid. Why? Because you know very well nitric acid is a volatile acid. Volatile means it displaces very easily. So it may decompose, and the nitrate radical, since you know very well a nitric acid is HNO3. So it will dissociate as H plus and NO3 minus. Right? So NO3 minus ion which we have formed, it might interfere with the electrolytic reaction. And as you can see, the sulfate ion SO4, they are not interfering, but they are remaining in the solution. Also, the
Yes,
current is
ma'am.
passed for a prolonged period of time. That is until the gas is collected, we have just passed the solution, we have just passed the current, right? This ensures that the saturation of gases in the electrolyte is solubility of oxygen. What I'm trying to say, that as you know very well, the both the gases are present above the water. It means they are soluble. The hydrogen also is soluble in water, and the oxygen also is soluble in water. It is affecting the factor solubility. Now, talking in terms of cathode, the hydrogen ions are going to migrate at cathode. The negative ions are going to migrate at anode. Anode, we would be getting the OH minus ion. That is the factor which we are talking about is a preferential discharge. Got the topic?
Yes,
Then
ma'am.
concentration of SO4 minus ions of the anode will increases. Why it will increase? Because as you know very well, from H plus ions will be liberated in the form of hydrogen gas. Hydroxyl ions, they are forming at the anode, and SO4 ions are remaining in the solution. Again and again the current has been passed. So the concentration of SO4 H sulfate ions will be increased, and which will increase at the anode and decrease at the cathode. So, but the total concentration, as we have read, the positive ions are equal to the negative ions. So, but that overall, the total concentration of sulfuric acid will remain same. Why it will remain same? Because of the passage of the electric current, the experiment will continue until we will get the desired product, right?
Yes.
And as we switch off the current, the reaction will again come at the starting point. So now the ratio of the hydrogen and oxygen, as I told you, the hydrogen is we are getting two volumes, and the oxygen we are getting a single volume. Right? So H2O we have written here for the formation, showing the two volumes of hydrogen and one volume of oxygen dissociating as H2 and O2, both present in the gaseous form within the respective electrode. So dissociation of acid, we have read this almost 2-3 times. Strong acid, how they are decomposing, and the weak acid, how they are decomposing, right? So you can just have a reading of this. We are going towards our next preparation.
Ma'am, could you just explain that dissociation of acids?
Dissociation of acids, you know very well, we have two acids, strong acids and weak acids.
Oh, yes,
Then
yes.
you know very
We
well,
have read.
we have read this one.
We have read. We have
Talking in
read.
terms of our
Yes.
last preparation, that is the copper sulfate, important one. Well, all of the three are important, obviously. Copper sulfate solution. So you know very well, aqueous. The electrolyte we would be taking will be obviously copper sulfate, right? Then the
Yes.
anode are there, and we have taken here the copper anode and the copper cathode, being an active electrode, not the inert electrode, right? So the
Yes.
electrolytic cell has been shown above. The electrolyte is the aqueous copper sulfate. The electrode we have taken both are the copper. Temperature is ordinary. The current we are passing is 3 ampere. So copper sulfate, it is in the aqueous state. So obviously the water will be present there. So copper sulfate will distribute as Cu plus and SO4 minus. This you know very well. Since it is in aqueous state, then H plus and OH minus ion. Now in this case, as you can see, all the four ions are entirely different. Right? Now how the reaction is going to proceed, that the reaction of cathode, as you can see, the metals get deposit. So copper will discharge at the cathode by the accepting two electrons, forming the copper as a neutral
Uh,
atom.
uh, Neutral
Yes.
atom.
Yeah. So the
Copper
product
will
of the
accept. Copper will accept.
no, copper will lose by losing it from the ion, and by
So why the
accepting it from the copper neutral atom.
copper will lose two electrons, right?
Yeah.
So, yeah, so why are you like? Yeah, you said that copper will gain two electrons and form neutral atom.
Look, the reaction is a two-step mechanism. Like, for example, copper sulfate, we got a copper 2 plus ion. So, we know very well copper 2 plus ion we got by the losing of the electron, right? So, here, as we know that this copper is formed by the losing of the two electron, and to complete this, to balance this electron, it would require two electron to make it a neutral atom. Not talking about the valency. Losing work is done here, till here, right?
So
After losing.
if it has lose two electrons, it is already stable.
No, if it has two electron, it is stable. It is stable if we talk in terms of the noble gas. But we are studying the electrolysis and not the electronic configuration. In terms of electronic configuration, it is stable. But we are reading the electrolysis, the passage of the current. And when we were reading the electrolytic configuration, we did not read about anything about the passage of the current, right?
So
So that's
different
why
concepts.
one additional process and one additional step is included here. That being stable, after accepting two electrons, we have to make it stable. That is the neutral.
So if you were reading, I don't know, like a chemical bonding something, then it would be already stable, CO2 plus.
Yeah. In terms of electronic confusion, if we have read it in the chemical bonding chapter, it is stable. That's why the electrolytic definition in the definition of electrolysis, the last word is to form the neutral atom. Okay, so
Ma'am,
the
just a
copper.
minute. I'll be there. Just a minute, ma'am.
Okay.
Yes, ma'am. Ma'am, you're not audible. You're muted.
Yeah, I guess I muted myself. At the cathode,
Yes,
as we
ma'am.
can see, we got the copper metal, respective copper metal at the cathode. Talking in
Yes,
terms
ma'am.
of anode, the copper, now you know very well, the copper has formed itself a neutral atom, right? And
Neutral
also we
atom.
have taken the copper, which is an active electrode. Now, if we would have taken the inert electrode, then the reaction would be the reaction would be OH distribution of the OH minus ion.
Water and oxygen.
Yeah, but we have taken copper as an active electrode. Again, the reaction will proceed from the copper neutral atom. Again, it is going, as you can see, the reaction is showing copper minus 2 electron. Again, it is forming the ion. Why this particular reaction is again happening at anode? Because we have taken an active electrode, which will participate in the reaction. Understood?
Yes, ma'am.
So that's why now we are getting SO4 minus ion and OH minus ion. Both the negative ion, as you can see here also, which are going to migrate at the anode. And neither of them are discharged. Why neither of them are discharged? Because they are both remaining in the solution. SO4 minus ion and OH minus ion. Right? So the product at the anode we will be getting will be nothing. Just the ions. We would be considering ions as a zero because we are just talking about the gases or the metals.
So that CO2 plus and CO2 plus ions, the concentration of them will increase.
Yes, the concentration of copper ions will increase, giving imparting it a more darker color, the more darker blue color.
So, ma'am, the suppose the alpha angle that is the between the both of them will be like constant because CO2 plus and both are CO2 plus ions, and at the anode or cathode, even though they are being produced by different forms, like by at anode, the electrode is only producing CO2 plus, and at cathode, CO2 plus ions migrate, right?
Yes. Yeah.
So, ma'am, the angle alpha will be same both.
No, the angle alpha won't be same in both the cases because of the presence of this active electrode. It would be same.
Ma'am, I thought I got disconnected. I
Yeah,
think
no
I got
problem. Yeah. I was telling you, you were asking me about the angle. So I was telling you, if
Yes,
we
ma'am.
would have taken the inert electrode, the angle would have remained same. But now we
Yes.
have taken an active electrode, so everything will be changed. The angle, the concentration, the color, everything.
So it won't be same in any circumstances.
It would be same if you are taking an inert electrode. Then the as your angle would remain same, and the reaction will continue in the good manner.
Excuse me, ma'am. I have one more doubt. Like you were telling about that probabilities one, right? the
Yeah.
Schrodinger equations and all. So
Mm.
the formation of the ions and all or anything is a probability, right? Because the universe formation of the universe and the particles is probability according to the particulate theory.
Yes,
So
according to the quantum mechanics, it is probability, not according to all the scientists and all the fields of
in
science.
in quantum mechanics, according to the particulate theory of that, everything that particles do or exist in any state is a probability.
No, according to that theory, they said that the particle exists in the two form. That is not probability. The particle exists in two form. The
Forms
wavelengths.
is yes, but the like Niels Bohr, a famous quantum mechanics
Yeah.
scientist, said like
Mhm.
if you observe one particle, observe its state. Suppose one particle is doing X thing, and when I observed it, it's doing Y thing.
Yeah.
So my observance has some kind of impact on the particle itself.
Yes, because it is in that case we have put it in a on the, as you know very well, there are three directions or the three axes, the x-axis and the y-axis and the z-axis.
Yes,
Right.
in
So
three
obviously
dimension
you are putting
universe.
any particle in the x direction. Obviously it will be show some activity, other activity on the y direction and in the z direction. However, z direction is a hypothetical one.
But that direction, according to a third dimension universe, should exist.
Yes, it is existing. That's true. According to the 3D dimension, all the three direction exist.
In two dimension, it will cease to exist.
Yeah.
Ma'am, can I share one equation? Like I had one doubt. I could not WhatsApp you actually. I just forgot about it. Can I just now just share one
Yeah,
thing?
you share to me. You just share. I'll explain tomorrow. You can just share.
Oh, okay, ma'am. I heard this equation like I had one doubt. So
Yeah,
like
yeah, sure.
this is the integral, and
Mm,
there's the partial derivative of psi, and then
mm,
a derivative of t
mm.
with negative. Just a minute. Is it visible?
Yeah, it is visible. Minus h vector you have used here.
Hamiltonian.
Yeah, Hamiltonian vector. Yeah.
Yes, IH. So partial derivative of upon the psi upon partial derivative of t minus Hamiltonian I, which is a
Mm,
complex number,
yeah.
and then you'll have S. That's S. S
What
naught,
is
to be precise. S naught will be the displacement of the particle,
okay?
where I is equal to square root of minus 1.
Yeah, not square root, under root of minus one, right?
Yes, under root, sorry. Under root of
Mm,
minus 1. And
okay.
psi could vary. Psi does not have any.
Yeah,
We cannot define
obviously.
it.
Yeah.
So, according to this, the formation of the universe and the
Mm,
particular theory is a probability. Like if I take one particle, it is in S state, and its
mm,
displacement is S naught. And when I observe it, its displacement is S naught delta dash. So it is
okay.
itself is a probability when I observe it. Now,
Mm,
when another observer observes it, it may mean some another state. Who knows?
yes,
we
obviously.
cannot say we cannot say that this one particle this will be in this state 100%, and that's not
Mm,
possible, right?
yeah,
So
yeah.
how are we so sure with the formation of compounds and all? Compounds are after all made up of particles, right? If I am correct, like
No, look, when you are considering this particular reaction, your reaction is stating that this particular thing is made up of particles, right? But
yes.
talking in terms of the ions, we know we have, it is not talking in terms of ions, is not probability. It has been proved that this party that we call these particular particles as atoms or the molecules or the ions, or when they combine, we call them as the element. These two
Yes,
are
so
the
it is
different parameters.
experimentally being proven, so this is contradictory to this equation itself.
Yes, it is contradictory to this equation itself. That is true.
Because, like, anyways, if you say quantum mechanics or chemistry or any type of
Yeah,
mechanics, they should have some, what you say, points where they must meet. After all, we are studying about the same electron or the same atom or the same compounds. It does not matter how we are looking towards them. They should have some, what to say, meeting
yeah, I
point.
got
There
you.
should be some, like, In classical mechanics, quantum mechanics does not make sense, and in normal mechanics, quantum mechanics does not make sense. Now,
Understood your doubt.
why is it like that? We are studying the same phenomena,
Yeah, we are
but
studying the same phenomena, but in the different fields, different aspects.
there should be some meeting point, right? If I'm saying A has some characteristics and I'm studying that, I'm studying
Hmm.
electron spin, then A would be same, and it does not matter. Like if you're studying quantum mechanics, relational mechanics, rotational mechanics, but A
Yeah,
is same. A will
yeah,
not
it's in
be
everywhere. Yeah,
something. A is not any real element. Just hypothetical. I'm saying if A is
yeah.
any.
Okay, I understood your question. I'll try to find out a particular evidence along with my explanation to you. Okay.
Yes, ma'am.
Okay. Thank you so much.
Thank you, ma'am. Bye, ma'am.